So types of solutions that could be made are solutions that are acids or bases. And here are some basic properties of acids and bases. An acid has a sour taste and a base tends to have a bitter taste. There tends to be no texture with acids. There might be a reaction on your skin or your hand, but bases will feel slippery. And if you imagine a base like soap, because soap has usually bases in it as part of its chemical properties, it feels slippery on your hands. If you have phenolphthalein and you put it in an acid, it will remain colorless, but in a base, it will turn pink. If you put red litmus paper in an acid, nothing will happen. But if you put blue litmus paper in an acid, it will turn red. And conversely, if you put blue litmus paper in a base, nothing will happen. But if you put red litmus paper in a base, it will turn blue. If you put a metal in an acid, it will react to form hydrogen gas, but in a base, there'll be no reaction. And if you have a carbonate, like sodium bicarbonate, so baking soda, if you put it in an acid, it will react to form carbon dioxide gas, which you probably remember from doing baking soda and vinegar as a child. But if you put a carbonate in a base, then you're going to have no reaction. So there's some basic properties, differences between acids and bases. An example of an acid would be like aspirin, an anti-inflammatory painkiller. An example of a base would be like sodium hydroxide. It's used in some strong soaps. Other acid examples would be like vinegar or a base like polyurethane. Hydrochloric acid is used in PVC manufacturing, so the plastic piping. And a base could be like ammonia used in fertilizer or some cleaning products. So they can be solids, liquids, or gases, depending on the temperature and the pressure on that acid or base. And here's some structural formulas. An acid will have your hydrogen ions and the base will end up having your hydroxide ions, giving it its particular properties. Vitamin C is an acid. Vitamin C is also called acetic acid. And so that's an acid. Baking soda is a base. It's got a carbonate in it. Lime juice, orange juice, or citric acids are acids. Carbonated beverages are acids. There's carbonic acid in a lot of your carbonated beverages. Soap is a base. Water would be something neutral. So anything with a pH of 7, it would be a neutral compound. If you have hydrangeas in your gardens, or if your moms have hydrangeas, they actually will react to acidic or basic soil. So if you put your like a base type of fertilizer on your hydrangea, it'll actually turn pink. But if you have acidic soil, it turns blue. So it actually is an acid-base reaction, giving it its color. So here's your pH scale. 0 is extremely strong acid, like battery acid. 14 is extremely strong base, like drain cleaner. 7 in the middle is neutral, like pure water. And then anything less than 7 is got acidic properties to it, and anything greater than 7 has basic properties to it. So in particular theories of acids and bases, they are described in the way that they behave in water. So acids dissociate in water to form your hydrogen ions, and bases dissociate to form your hydroxide ions. So hydrogen ions tend to be acidic properties and hydroxide basic properties. And you can see that here in this equation. So this is hydrochloric acid. It will dissociate in water to make hydrogen ions and chlorine ions, and sodium hydroxide will break down into sodium and hydroxide. Acids with 2 hydrogen ions are diprotic acids. They can ionize into your 2 hydrogen ions. Or tri would be 3 hydrogen ions. So 2 hydrogen ions would be like sulfuric acid or carbonic acid. So there's 2 H's in those compounds. And if it's a triprotic acid, there's 3 hydrogens like phosphoric acid. And they do tend to dissociate in 2 steps. So here you've got your hydrogen ions breaking down into still a negative ion, and then it will further break down into another hydrogen ion. So it breaks down into 1 hydrogen ion, and then a second reaction will break down into its second hydrogen ion. And the same with triprotic acids, you've got 3 reactions, each producing a hydrogen ion. The best way to describe an acidic solution is by stating the concentration of the hydrogen ions. And the concentration of the hydrogen ions will create either stronger or weaker acids.